Hello, famoticians. That didn't really work. I was trying to combine Mr. Youngsaber's hello statisticians with family, because I always say hello family. Famoticians, that's not going to be my intro, family. Not going to be my intro. I'll keep working on it. This video hopefully will be a quick but sufficient and thorough video to walk you through the third example from sample means. We didn't quite have enough time to get through it in class today, so I told you guys that I would make a separate video. You had two practice problems so far using sample means. We did a problem on bottling soda. And then we did a problem about airline passengers. Now, what's different about this problem is that this problem is going to ask us to evaluate a claim. So we're going to use the probability that we get to decide if we should reject a claim or not reject a claim. So, battery manufacturers are constantly searching for ways to build longer-lasting batteries. A particular manufacturer produces AA batteries that are designed to last an average of 17 hours with a standard deviation of 0.8 hours. So I'm having a feeling that that is going to be important information for us, so I am going to highlight that. They last an average of 17 with a standard deviation of 0.8. Quality control inspectors select a random sample of 50 batteries during each hour of production. Then they drain them under conditions that mimic normal use. So they're testing these batteries to see how long they last for. The average lifetime of the 50 batteries was 16.718. So they take this sample, they calculate the average time it took to drain the batteries, and they get an average of 16.718 hours. That seems pretty close. If they're claiming 17 hours and it lasted 16.7 hours, that seems reasonably close to me. The question, though, is, do these data suggest that the production process is working properly? Find the probability of obtaining a sample of 50 batteries with a mean lifetime of 16.7 hours or less. So, if the production process is working correctly. So, if production process is working properly, then the population is N normal with a mean of 17. In fact, maybe I should use symbols in this just to keep it clear. Mean of 17 and sigma of 0.8. What they are asking us to calculate is, what is the probability we would get the sample that we got or less? So the question is, what is the probability we would get this sample if the process is working properly? Show your work, and based on your answer, do you think it's working properly? Why or why not? So essentially what we're finding is this. Now, you are not expected to write this down. I am just trying to be clear about what this problem is saying. So if things are working as they should, this is our info. What is the probability that we would get a sample value like the one that was obtained? I was going to say, like the one that was gotten. That does not sound right. Okay, so we start this by saying our sample will come from an normal distribution with a mean that is equal to the true parameter, which is 17 hours, and a standard deviation that is equal to the population standard deviation divided by the root of 50. This gives us a standard deviation of 1131. Okay, before we do any calculations, we just need to verify that we can actually use a normal distribution. So we use this. Sorry, you can't see that. This is our reminders. So is our sample size or our population approximately normal? They don't say what the population shape is, but n is equal to 50, which is greater than or equal to 30. So the central limit theorem applies. Central limit theorem is the reasoning or the why behind why we can use a normal distribution. Next up is the random condition. They take a random sample. So a random sample was taken. So we're doing this to verify that we're allowed to do this. And then lastly is our 10% condition. So our population is all batteries produced in 1 hour. So the question is, do we think that 50 is 1/10 of all of the batteries produced in an hour? Yeah, I think it's reasonable to assume that this is true. It is reasonable to assume this is true. Okay, so we checked our 3 conditions. Now we can move on to our probability. The probability that we would get a sample less than or equal to, sorry, that should have been less than or equal to up here, 16.718 is the same as the probability of some z-score less than that. So to find that z, we would do 16.718 minus 17 all over 1131. This gives us -249. And I want to remind you what this z-value means. This z-value means this number of hours is 2.5 standard deviations below the average number of hours that the battery should last. So this is 2.5 standard deviations below the mean. So this probability is going to be small. It doesn't seem like 16.7 is that far away from 17 hours, but now that I'm seeing its z-score, I'm starting to feel like, oh, okay, yeah, this is pretty far away from the true value. When we go to our z table, we're going to see that. We're going to see that. So we go down to -2.4, slide over to 9, and I'm getting 0.0064. If you like to write that as a percent, that's 0.64%. It's not even one full percentage point or percentage value. So, does this suggest that the production process is working properly? No. If the production process is working properly, the chances that we would get this sample value is less than 1%. So we're talking essentially 0. So this is actually convincing evidence that the production process is not working properly. So we're going to answer this question. Do these data suggest the production process is working properly? So I do not believe the production process is working properly because this or these data give convincing evidence against, well, I guess I shouldn't say against. I do not believe that the production process is working properly because these data give convincing evidence that it's not. The probability of getting a random sample of 50 batteries with a mean lifetime of 16.718 hours or less is 0.64% if the process is working properly. It is not plausible to get X bar less than or equal to 16.718 if true mu is 17. Oh, sorry about that. This is not the only way that you could write this. What you have to have is you don't think it's working properly. Why? Because our probability is too low. So that indicates that the process probably isn't working properly because we did get a sample that low. So if it's working properly, the chances we would get that sample is less than 1%. Well, we got the sample. We actually got that sample value. So that says the production process probably is not working properly. I do not believe the production process is working properly because these data give convincing evidence that it's not. The probability of getting a random sample of 50 batteries with a mean lifetime of 16.718 hours or less is 0.64% if the process is working properly. It is not plausible to get this sample value if mu is 17. So you could probably leave this last sentence off. You could probably leave the last sentence off, and the stuff before it would be sufficient. But essentially, you're indicating that the chances we would get this sample value are so low that that must mean the process is not working properly. Okay, so that's it for evaluating a claim. Hopefully that helps. Make sure that you check your Can You Do Solutions 53 to check your understanding and make sure that you know what you're doing with sample means.